This video will be on OCR MEI Statistics, mainly sampling, and we'll go through some definitions and also the types of sampling. It'll be a very much regurgitation video, so I would very much just state the definitions and the types of sampling and just move on to the next one. Going through some of the definitions. Population we define as the entire set of individual objects / entities that we're interested in and want to make a conclusion about. A census is an investigation into the entire population where data is gathered to identify facts about each individual. A sample is a subset of the population in which statistical investigations can be carried out and conclusions can be made. Samples are drawn from populations. A sampling unit refers to an individual element of a sample. A sampling frame is a list of all the units of a population from which a sample is to be drawn. The difference between a sampling frame and a population is that a population is like the theoretical idea of each of the sampling units, and a sampling frame is the physical tool that lists all of the sampling units. A statistic is a quantity calculated solely from a sample without using any information about the population. Those are some general definitions. Now going to some of the symbols. Mu refers to the population mean, which is very simply just when you have your population, you calculate the mean. Sigma refers to standard deviation. If you make any sort of calculations using information about the population, it is not classified as a statistic because as we previously mentioned, a statistic is not you can't use any information about the population. When you have a quantity like x bar or x mean, it is not necessarily equal to mu because x mean is derived from a sample, whereas mu is the population mean. It's dependent on how accurate your sample is. If it's a very unrepresentative sample, then your x mean value will probably be very off. And if it's pretty accurate, then it's going to be pretty close. A census in the UK is taken every 10 years to collect information about people, and the reason for that is because it takes a lot of time and costs a lot of money. A representative sample is a sample which mirrors the key characteristics of a population, and the converse is just a sample which does not mirror the characteristics of a population. Biased sampling is a type of survey bias that occurs when a study does not use an entirely random sample, and if you want to take a sample without any sort of bias, each member of the population should have an equal chance to be in the sample. Going into the types of sampling, there's like 7 we need to know, kind of 8, but we need to know simple random sampling, proportional stratified sampling, and normal stratified sampling, cluster sampling, opportunity, systematic, quarter, and self-selection. So, let's just start going through them. In a simple random sampling procedure, each member of the population is equally likely to be selected. It is possible for sub-elements to not be permissible. A sampling frame is required and the selection have to be made randomly. Pretty self-explanatory. The advantages are that there's no bias, it's random, and is likely going to be representative. The disadvantages is that it could be high cost and requires an exhaustive, accurate, and up-to-date sampling frame for it to be representative. In stratified sampling, there are many different subgroups known as strata. Some examples there, and samples must be taken from every stratum, and if the numbers sampled in the various strata are proportional to the size of their populations, this is known as proportional stratified sampling. The selection of items to be sampled within each stratum is usually done by simple random sampling. Stratified sampling will usually lead to more accurate results about a population / individual stratum. The advantage of this is that it's random and unbiased. The disadvantage of that is time consuming and sampling frame. That should be sampling frame. 1 second. Sampling frame required. For cluster sampling, this also uses strata, but items are chosen from one or more of the groups. We can call them clusters as well. The subgroups are known as clusters. It is important for each cluster to be relatively representative of the whole population. For example, investigating the incidence of a particular parasite in the puffin population, it would be impossible to use simple random sampling. The advantages of this are it's representative. The disadvantage is not strictly random and can risk some sort of bias. But these definitions are from the textbook, so some of the examples and everything quite random. For opportunity sampling, it's used when circumstances make a sample readily available. Since this method of sampling is usually contingent on circumstances, it is usually seen as the weakest form of sampling. It can be useful for specific case studies and to investigate the behavior of particular groups, and can also be used for an initial study. It's very easy to implement and can risk bias and an unrepresentative sample. For systematic sampling, it's a method of choosing individuals from a sampling frame based on some regular interval, or I guess choosing every nth item from a sampling frame. So like if you choose the number 38, and then you just sample for after every 100, so the 38th index, 138th index, 238th index, etc., etc. This is particularly useful if you want to sample items listed in a spreadsheet. When using systematic sampling, you have to be aware of any cyclic patterns within the frame. For example, if like your sampling frame is ranked, then if you sample at the same index, your sample is going to be made of comprised of like sampling units which are like very similar. And that also links to the disadvantage, which is like risks missing sequential patterns. But the advantage is that it's evenly spread out and also is like random. Quota sampling is often used by companies to like employ people to carry out opinion polls. An example was specified for this one, but essentially it's like you're sampling based on some sort of quota that is predetermined. So let's say if I have a sample of 40 women and 60 men, and in my sample I want 10 men and 10 women, that is predetermined, and regardless of how my sampling frame changes, I need to have 10 men and 10 women. And this is oftentimes I ask, what is the difference between proportional stratified sampling and quota sampling? The difference is, with proportional stratified sampling, your proportions are based on the proportions of the population, but in quota sampling, your proportions are based upon your needs. So they're predetermined and do not vary regardless of how the proportions of the population vary. For proportional stratified sampling, if I had 60 women and 60 men, I'll sample 30-20. But if they happen to switch around, 60 men, 40 women, then my how I sample will be 30 men, 20 women, like that. It can change quite easily based on the proportions of the population, but not in the case for quota sampling. For self-selecting sampling, a sample is self-selected when those involved volunteer to take part or are given some sort of choice. An example would be some sort of online survey where people just very much put themselves forward to be within the sample. It's very easy to carry out because you just wait for the sampling units to roll in, and then the disadvantage is that it's non-probabilistic, people have to come in, and also you might find people who are feeling particularly strongly about some certain area or the reason that you're sampling for, and thus will choose the questions at which they answer. So that can lead to a biased sample or unrepresentative sample. Another thing that's important is the definition of outliers. When you're taking samples, sometimes you need to outline some outliers. Is defined as an outlier is when it's 1.5 times the interquartile range above the upper quartile, or 1.5 times the IQR below the lower quartile, depending on which one is nearest. So essentially, as a short definition, an outlier is 1.5 times the IQR away from the nearest quartile, or another definition is that it's 2 or more standard deviations away from the mean. And that's it. Also, another thing, for quota sampling in exam questions, the keyword is until, because you're not going to stop sampling until you finish your quota, right? So yeah, that's just that's a easy way to kind of spot quota sampling. But other than that, that's basically it.